Our final topic for our Business 375 class is Chapter 15, which is short-term scheduling. So let's get started. So there is a strategic importance to be able to schedule short-term stuff very effectively and efficiently. The idea is that the faster we move goods through the facility, that means we're utilizing our assets better. That's our people, our places, our machines, that kind of stuff. And it should help lower costs. Additionally, we might free up capacity based off of those resulting faster throughput times, and also get stuff to customers faster and on more dependable delivery schedules, making customers happy. So what exactly is scheduling? It deals with the timing of operations. Basically, how do we allocate and prioritize the demand from the customers in order to meet our objectives? And our objectives can be one of many different things or multiple things, and we'll get to that in a minute. Significant issues when we talk about short-term scheduling include these two big things. One is the type of scheduling. Do we do forward or backward? Or the criteria for the priorities, which is basically how do we allocate demand. So let's look at each one of those. So forward scheduling starts as soon as the requirements are known. It produces a feasible schedule, though it may not meet due dates. Now that might be a bit confusing. Remember, feasible means it's possible, it's doable. So if it doesn't meet the due date, isn't the due date a constraint? Well, if it's a constraint, then how can it be feasible? Well, what that means simply is that due dates are soft constraints, not hard constraints. So if we miss the due date, maybe we incur some penalty or something, but it's not a hard constraint, it's a soft constraint. And forward scheduling often results in the buildup of work in process inventory because we're not thinking about which machines or work centers are going to be used based on different jobs at different times. So we're not really taking a holistic or a global perspective when we're thinking about all the different jobs. On the other end, we have backward scheduling, which begins with a due date and then schedules the final operation first and then works backwards through the process, saying when it should hit each particular workstation or machine. The resources may not be available to accomplish the schedule, so it might say it needs to go through the painting department on a certain day, but the painting department might be occupied with some other job. So here we're trying to meet the due date, but we may not have all the resources to do so. So often we actually use a combination of both forward and backward scheduling approaches, where we kind of have to trade off between a feasible schedule, so each of the workstations are available, with the customer due dates. And of course, if we put more resources towards it, we might be able to make some of that stuff change. And then the second big thing is the scheduling criteria. So our goal when we schedule is to optimize, that means to make the best decision, the use of resources, that production objectives, so that the production objectives are met. Some of those production objectives might be minimize completion time, so get stuff done as fast as possible. Maximize the utilization of the facilities. So the idea there is the machines and people are expensive. Let's have high utilization rates for those. Minimize the work in process inventory, the WIP. So go back to chapter 12 that we just finished. You know what WIP is, and so the idea there is money is tied up in inventory. We don't want that. We want to use that money for other things, so we want to reduce the work in process inventory. It also helps declutter perhaps the production setting as well. And then another objective might be minimize customer waiting time. So those are four broad areas that are objectives that we might see. From this chapter, chapter 15, we are interested in two basic models that we're going to look at. The first is the assignment of jobs to machines, called the assignment method, or people or workstations. And the second is sequencing a set of jobs on a single machine. So let's look at the assignment method first. So it's a special class of linear programming models. Ooh, yay, my favorite. Go back to Module B. That assigns tasks and jobs to resources. The objective is to minimize cost or time, so we'll need some kind of table giving us that information. And then we want only one task or job assigned to one machine, so we want a strict one-to-one mappings. The book suggests doing this by hand. That's way too tedious. It's a special class of linear programming. We learned how to use Solver before, so let's use Excel and Solver again. So let's look at an example. So here we need a table of cost or time. In this case we have cost associated with each possible pairing. So here we have 3 different jobs that must be performed by 3 different typesetters, or people I guess we could call them, and how much it would cost for job R34 to be accomplished by typesetter A, B, and C. All right. So we see that there's some trade-offs. So this is a small example. You might be able to find the best solution by hand. You can certainly find a good solution by hand without too much difficulty. But in order to find the best, we're going to use Excel to do that for us. So in this example, we need one decision variable for each possible pairing. So in this case, we had 3 jobs to 3 people. So 3 times 3 will have 9 decision variables. Each decision variable will be a binary variable, meaning 0 or 1. It'll be a 0 if that person's not assigned to the job. It'll be a 1 if that job is assigned to that person. And then we should have a constraint that says each job gets only one typesetter, and each typesetter gets only one job. And then our objective function will be minimize the cost of those pairings or assignments. So let's move over to Excel and take a look at this.